Scott, vets are consumers of scientific literature, but they're also producers of it. Now, they don't get a lot of time to keep up with the literature, so to make the most of their time when they do, what are the things that they should be looking out for?
That critical time, that small amount of time we do get to sit and read, should be used really effectively. And I think one way of doing that is to read the good literature. But there are things that can help us do that. There is the idea of what they call the hierarchy of evidence. So basically what the idea there is that there are some studies that are more valuable than others. So for instance, at the bottom of the pyramid, the least valuable to us as clinicians might be the latest whiz-bang molecular biology test tube stuff. So someone runs a study on a gene in monkeys' bladders that's associated with cancer or something or other. Now, it's lovely science, but that doesn't help me as a clinician do a better job for my clients. So coming up the pyramid, so becoming more relevant and more useful to me, is things like editorial and opinion, so other people's experience. Yeah, they have some value, but it doesn't have as much value, for instance, as what's called an observational trial. So someone who's gone out and followed a bunch of animals over time and has documented things properly and drawn some conclusions. While they're useful, you can get things like bias and confounding and some of these other things that can make you look at the results and say, I'm not quite sure this is really real. So the internal validity, to use the jargon, is not strong. So coming even further up the pyramid, there are a thing called controlled randomized studies, and these are the kind of classic studies that people might think about, where you take a group of animals and you randomly assign them the treatment, and the person running the study controls which cows or which animals are treated and which ones aren't, and they really specifically control on what day animals are blood sampled, for instance, or followed up. So, you know, tightly controlled situation where you can be very confident, in fact, if you get a positive answer, so the treatment works or doesn't work, you can be very confident that's right, and conversely, you can be very confident to say if there's no result, then that's probably real. Now, the next level up the pyramid, if you like, is taking a number of these studies. So there might be a study done in New Zealand, one in Australia, and one in the United States, and putting them together in what's called a meta-analysis. And so what meta-analysis allows us to conclude is that, you know, a treatment is tested in different physical environment with different animals by different experimenters, and if the result is consistent across a number of studies and across a number of places, we can be very, very sure, you know, 99% sure that when someone says something, it is right. And then right at the top of the pyramid is what's called a systematic review, and what that does is start at the basic science. It says, why are we doing this? What's the physiology or pathology? It goes through all the field studies, and it brings together all the conclusions, the rationale, the physiology, the pharmacology, the field studies, the real-world field studies, and comes to a conclusion. So you're going to sit down and spend some time reading some articles, go to the top of the pyramid, you know, go to randomized controlled studies. Now, to understand whether even a randomized controlled study is well written, there's a thing called the consort statement, and I'd encourage people, you can just go and Google it, and what the consort statement does is really just give you a list to go through and says, well, was there a hypothesis? Did they actually do power statistics? Were there enough animals there? Were the lab techniques they used properly described and validated? Did they actually present the data well? Did they draw conclusions? So you can put a lot more store in a study that's been peer-reviewed in a well-respected, highly cited journal than, you know, Googling something or other and finding, you know, some person's opinion that the blue juice is better than the red juice.
Now, vets, of course, also carry out their own research. What are some of the steps that they should be thinking about before they rush off and start collecting data?
I mean, to run a research study properly is actually, I won't say a specialist thing, but involves a series of logical steps. And, you know, the biggest issues that I see is where people haven't sat down and done the planning. And an old academic told me many, many years ago that when you run a research trial, you spend a third of your time planning before you even start, just sitting and thinking and getting the questions right and designing the study right. A third of it doing the fun bit, which is out working with the animals, and then a third of the time doing the analysis, lab work analysis, and writing up. And I think that's a very good guidelines. There are a number of fairly logical steps you go through. One is actually thinking about the question. So, you know, you might wake up in the morning and say, oh, there's a new trace element product on the market, does it work or not work? So that's the big picture question. You then might say, oh, well, this product's got selenium and copper in it, so what I'm actually interested in is to say, if I supplement deficient animals with this product over X days at X dose, and I measure copper and selenium, you know, X weeks later in this subset of animals. So what I'm driving at is a really specific hypothesis. So you've now got a really robust hypothesis, and you then do your power stats and you say, well, I need to measure 50 animals in each group to give myself a pretty good chance that I'm actually either going to be able to accept the alternate hypothesis. I'm going to say, yes, there truly is a difference, or in fact to reject it. So I've got enough animals to be very clear that what I'm doing is actually going to give me an answer, one way or the other. And there's nothing worse than just getting to the end of the study and saying, we didn't do it properly. Getting your design right, getting your power stats right, getting animal ethics approval are all important. You know, once you've got a framework, once you've got a protocol, you then need to think about, well, how do we actually run the study? What are the logistics of it? Once you've got all that right, you run the study and you get all these wonderful results coming in. You then need to work your way through it and check that the data's clean to verify it's right and there's not missing data or dirty data. Then do the analysis, do the write-up, and finally, and most importantly, actually drawing a conclusion and communicating that effectively. I think it's really important jumping on the phone and talking to someone or other who's actually got experience in running trials in the area that you're interested in doing. Now, whether that's a university academic or someone working for an animal health company, or you know, someone in a contract research organisation like our own.
So do your homework, talk to the right people before you start.
I think so, and you can save yourself a lot of time and money and grief. And you know, generally people really underestimate how much time and effort it takes to run to a study. The harder hurdles are at the front and the back. The actual bit in the middle, the actual doing the research, is the fun bit.